This is an exam question about electrocardiogram. Don't say electrocardiograph, it's a cardiogram. And it says an ECG electrocardiogram trace shows electrical activity within a person's beating heart. Figure 4.1 shows a normal trace. So this is the normal trace. We've got sections P, R, T, and back to P again. So P is atrial depolarization. So that's when the atrium are contracting. The wave of excitation will pass across the atria and cause the atrium to contract. R is ventricular depolarization. So that is when the electrical impulse is passing over the muscle walls of the ventricles, causing the ventricles to contract. And T is ventricular repolarization. So that will cause the ventricles to relax. So that's when the ventricles relax. And we can see that one wave runs from P to P. So the question says, a trace after the administration of the drug digitalis, B. So B is when digitalis has been added. And a trace from someone whose heart has entered a state known as fibrillation. So C, this is fibrillation. And you can see a clear difference between this graph and a normal ECG from a normal trace. Again, it says C. P represents activity in the atrial wall. We've already talked about that. R is a contraction of the ventricles, and T is the recovery of the ventricles. So we've already talked through that. The question says, with reference to trace A, calculate the length of a single cardiac cycle, so that's one full cycle, and the number of cycles per minute. So we've got two calculations to do. So we have to use figure A, trace A, and we want the length of a single cycle. So if we're starting off when P finishes, which is round about 0.1. So again, here when P is finishing round about 0.9. So the length of a single cycle is 0.9 minus 0.1, which equals 0.8 seconds. So the length of a cycle is approximately 0.8 seconds. Right, we then need to use that data to calculate number of cycles per minute. Well, we know in a minute, that's 60 seconds. So we just want to know how many times 0.8 goes into 60 seconds. A lot of students will do the sum 60 times 0.8, which will then give you an answer of 45 beats per minute. That is incorrect. It's how many times 0.8 goes into 6 seconds, so it's a divide, so it's 60 divided by 0.8, which equals 75 beats per minute, or cycles per minute. A normal resting heart rate is between 60 to 80 cycles per minute. So use your knowledge of that to understand that if you did this calculation, 45 is probably going to be incorrect. Right, part B says with reference to trace B, state 2 effects of digitalis on heart activity. So we're comparing these 2 cycles. So first of all, we can see that T is a much greater length of time. So that lengthens the ventricle cycle, the ventricle contraction time. We can see that the entire cycle is finishing at a later time. So the digitalis obviously lengthens the cycle. Sorry, T is relaxation, and T lengthens the relaxation time of the ventricle. And then we're comparing R, it also lengthens the time for ventricle contraction. So they're the 4 things that we need to be talking about. The 3 things we need to talk about. So we've got the cycle lengthens. It's about by 0.1 to 0.2 seconds, how much it increases by. Ventricle contraction time increases, and ventricle recovery or relaxation time increases. So they're the 3 changes. We're after 2 of them.